another guy gonna get stuck on a house, and he's like, oh shit. It's so funny.
Yeah. You wanted to solve the So you said if I did all he wanted was just the one?
Probably the words.
I know, but like the answer was one. You didn't want individual answers for all the H's.
Everyone just screaming at Julian. He went home, and they were just rappers living in his house. White trash is so fun.
Do you guys know how to do the homework?
They need to have a.
I just beat
most of it.
I didn't know what I was talking.
I got like most of it.
We'll
Wait,
see.
what? Thanks. Homework? Do you know how to do it?
Kind of. Which one are you stuck on?
Okay.
All of it?
No, not all of it, but I don't.
Reizo can explain 43.
I don't like these. I don't know what to do, but I know.
I can explain this one. Reizo can explain that.
All right. What the heck? How do you do this? Hurry up.
I appreciate the ...
You do something. I don't know, but you get that answer.
You know what Miss Johnson does on her week off? And it's like a week and a half, huh?
She went to 2 different conferences
So-
that just happened to be back to back.
That's kind of.
So she's still working.
Well, was it fun though? Like
Yeah.
to
That's exactly
Wait,
what
what
you
did
do
you
for
guys-
43
Probably the
also.
second
Dang
one,
it.
probably not the first.
Yeah.
What did you do?
Okay. So
It's like this
So
completion
you
by
plug it
design
in to the
conference. It's
equation.
all like fluffy
I
talk.
didn't write down the
Yeah, where is it?
But then you multiply to get a common denominator. So that means like, so this one was already over
She
x
doesn't
plus
reply to
h
my
plus
email.
1.
Oh.
So
Yeah,
this
she
one
doesn't
was
reply to my
x plus
email,
1
dude.
up top.
She's just gone.
And then
What'd you
this
do?
one
Ask her,
needed
where are you?
the x plus h plus 1 up top.
She told me
So
that
then
I
you
asked
just
her
boil off the
earlier if I
top,
could
but
get her
not
to write me a
the
letter of
bottom.
recommendation.
Just
So then I
do
sent her an email for a letter of recommendation.
So then you
How'd
just
that
get
work?
negative 2
Who
h
knows?
on top, and then you FOIL off the bottom.
Find me.
And then since it's all over h, you could just say that it's multiplied by 1 over
I don't
h,
even know what that
because
brand
that's the
is. It's
same
like some
thing.
Swedish brand. I'll look it up.
Which turns out
You know, it's
to
like
be
IKEA.
the h on the outside that you can
You
Oh, this is Zara.
Yeah.
take out.
That's her
and
G
equation.
Dragon or something.
So then you get that,
And
and
she
then
How
you
would
just
you do
simplify
He's
it.
that K-pop artist. Man, I was in
Never
a.
figured that out for like the six.
No, that was Razor.
went
I
to,
figured
uh,
out that one just because of
I was in New York when G Dragon was having a concert, and I made a big mistake. I went to Midtown. I went to Koreatown. Like Asian American girls with weeaboos from all over the American Northeast. They just all flocked to Midtown. Like every subway car was full of just these
Oh,
girls
for that
screaming.
G-Dragon.
And they're like,
concert.
oh, G-Dragon, this guy. Yeah, and then I went to like this one store, and then I just had this long conversation with this one like cashier girl that was freaking out about it. She's like, oh, I caught a whiff of this scent, and I'm like, wow, that's pretty interesting. Spent like $1,000 in
How did you get
clothes.
number 6?
So at S equals 2, you would find the
Yeah, the
value.
new Balenciaga Crocs.
No.
Or the second?
Dude,
No,
they're
wait.
like Crocs, but they're
I'm
like
waiting
this
for
high
those
off the
Beluga
ground.
Yeezys.
So at
The
X equals
Crocs
2.
like this high up off the ground because they're platform
I've
shoes.
been using
I'm waiting for those Beluga
because I got
Yeezys.
that, but the internet kept saying that I needed 2 at the end.
Oh, that's not bad.
Yeah, just so you have this point.
What did I do wrong?
Well, what'd you get? What'd you get? Well, I did better than us.
I just gave
Yes.
Where did that
I don't even want to do this. I didn't think it was going to be graded. I was wrong.
I came from that age right there.
So that's
wow.
your equation.
But when the H is 0, that would well,
You
it's
sent
2
it to me,
plus 0
maybe.
is 0.
You know what clocks were a good
But you would
idea?
take out the H.
I mean, I guess you can
first,
destroy
and then
them
do
and
zero.
without
That's your
consequence.
algebra there.
But
That's
that
all
was
the
you
time.
guys know
I know how to do that.
I just didn't put it down.
They're the ultimate outdoor shoe.
Ultimate hiking. Hiking in Crocs.
So
Oh,
just
wait
think
a
of it
second.
separate.
I would too.
I didn't include
you
that.
study for,
It's not there.
I'm gonna do that
Never
right now,
mind.
actually.
How
I
sad.
think you should wait until
That's
after
okay.
the
That's
class.
all
I'm gonna do it during
I
this
didn't
week.
get 10 on either single.
I'm not even kidding at all.
The perpendicular one.
Oh, I didn't.
The only one I know
That's the only thing.
I'm feeling
is
disrespectful.
phosphate, and I think sulfate.
I mean, it's copper 1 and 2, and iron 3 and 4, and silver.
I think as long as you got the tangent line, you just reverse
Iron
the
4,
iron
iron 2,
integral of the slope and
Iron 2
then
and
plug
3
in
and
the
silver.
same coordinate.
Okay, hydroxide, HO.
My question is,
I fell asleep with
Negative. Oh yeah, I know that one too.
the
OH
flashcards.
negative.
so I
Sulfate,
understand
SO,
how to get
3,
it
2
to
minus,
molecular
4, 2
what
minus.
it is. Like what's
Ammonium,
and that.
NH plus,
It's not tangible.
NH4 plus. Crap, we're screwed.
Wait, which
Carbonate.
one's that one? Carbonate?
Carbonate, CO.
3,
Yeah, that's it.
I fell asleep with flashcards.
CO3, 2 minus, nitrate.
I don't know that.
NO.
I mean, you've seen it.
3, 2
No,
negative.
I don't think
It's
it's
in
gonna
your
be it,
note.
but
Well,
3 negative. Gosh, I think there's a way to actually think about
You
this
didn't take
rationally.
171.
Oh well.
It's definitely not in your notes. It's
Strictly.
Did you guys learn about the different groups?
You've seen it.
With,
Did you guys learn about the groups?
yeah, they're not the best.
We just
You
have
know,
to
we really
memorize these
learn.
things.
Intro Chem really is.
He said he's gonna give us basically anything and it's fair game. He'll give us the name and we have to write the chemical formula.
Yeah,
Or he'll give us the formula and we have to write the name.
that's how they do it later on. My gosh.
Based on all the groups and everything for the students.
I
Hey, we all made
thought
like
he told us-
60s
I
on
thought he
that.
told us which ones you have to memorize.
Well,
instead
yeah,
of
he
just-
did.
No,
tell us
he
which ones
did,
we memorized.
but then
I only have one.
In general chemistry, they don't tell you that.
Yeah.
They're just like,
They just
you
throw
know how
stuff
to
at
do
you.
it. And we all got 60s on the quizzes.
Yeah, Intro Chem's pretty easy, Sammy. It's pretty
I've
great.
got no.
I'm actually worried more about chemistry now than
It's literally stuff we covered in middle school in Mr. Field's class.
I
Like,
miss Mr. May.
and Mrs. G's class in 6th grade.
I didn't have history.
Oh yeah, she was a nightmare. Yeah.
She quit halfway through Sally's year because Sally had her for science.
Why didn't she quit?
She harassed a student, so her options were either quit or be
Why
fired.
how'd she harass a student?
She pushed him up against the wall.
What the heck? Why did
Because
she
they were being annoying or something, so she pushed him up against the wall to yell at
I know
them.
I
and
got
then
this
they
You
letter.
shouldn't even teach.
quit or be fired.
Sammy, she became like the president of like the Christian Students Fellowship. Their attendance dropped by like 75%. That's a great example right there.
I didn't even know that she was a Christian.
She's such an awful person. She just made that school the worst place to be. Oh yeah, right. Yeah, she's so awful, my dude.
The one time I ever went in her class was when I was in 6th grade, and Mr. Preach set me up there, and she was holding a wand. I
Yeah.
don't understand. She was just, when I came up and asked for books, one of the kids started talking, she pointed the magic wand at him and said, shh. And I was like,
Yeah, middle school was nice. I didn't have to actually learn,
right.
but now I have to.
Oh, that's a lot of writing.
Yeah, I know
This
this.
is never gonna work. I've got 3 pages left.
Chloe.
Lily.
Chloe.
Lily.
I got confused for a second.
Lily.
Let me get the legal pad. It's game over. Game over. The legal pad is coming out. No, wait, I don't have it. Oh, wait, I do have it. I do have it. Huh.
Did you actually clean your room last night?
Yeah, I did. I cleaned my room.
Good for you.
Did you see my Snapchat about how dirty it was?
Yeah.
I did. There was so many pictures.
Yeah. I write so much crap. Yo, this point slope formula got me thinking about my ex though. Whew. Wow. Is my ex. Is he just talking about how to do the tan line?
You mean?
Well, I mean, you do the derivative, do the tan
I'm
line.
going to start writing all this down because I need this.
We rated it.
All down.
Yeah, I'll just wait for you.
Derivative at value x equals a is at time of a equals lim as h equals 0 of f of a plus h minus.
Like that whole second page
Dude,
is yours.
Elise has
This
an
says the slope
Ethan Klein hat. H3, H3. Feet per second over. He's just writing stuff down. But you know what?
You got
I just get here early because stuff is mad inconsistent these days.
I still don't understand this.
Yeah, mad
I
inconsistent.
will show you the pattern we are following for this class.
I know.
That's nice.
I like
What's
that.
it like?
And by you can check out we're
Pretty
doing
easy thing without looking at like,
Yeah,
yeah.
it's pretty fair.
It's just.
How well are you doing with that? You doing pretty good in the class? Yeah.
I understand. Like 60, that's it.
Yeah, nice.
I don't understand what this one.
This is our pattern. It's like what?
Really cool stuff.
Okay, I know how to do
With
this.
8th grade calculating
Today's 5.
Convert
Or,
shell.
um,
So,
pattern.
got it
So
set up.
we're on
and it's
proving
like-
next term.
You're right. Man, I should look at that later. I'll take like a picture of it. This is quality information.
Yeah.
Yeah.
So they have to multiply to get.
I feel like throwing up again.
The left one by X and the right
I
one.
mean, I guess. I don't know what it is. It's
Check the
fine.
roll.
Yeah.
I want to check the roll. I started writing some notes, kind of a review of what we covered. To make sure we're really clear.
I'm just gonna look at
Oh, I'm
this.
thinking all I also. Yes. Check. Thank you. It's roll. There's forces. Ms. Klinger, did you get a chance to print out those grade labs?
Yes, they have them.
It was worth it. All of a sudden, we're getting on. That's really something.
Did you hear me?
Grades better.
Yes.
Okay.
Did they have them?
Yes.
Okay, that's for cigarettes. Sorry.
Again, this is just some kind of review notes. What we've been. I'm going to add to it on the next one. I'll leave the camera on there so you can take a look at that. Just to review. What we call this is called a derivative at a point. This is called a point derivative. In a moment, we'll review function derivative. Derivative at a point is defined similarly to derivative of a function, but you're just at a single point, a given a value, whatever a happens to be. This number that we get, this gives me a number, this value. So, value, it's the slope of the line that's tangent to the original function at a point where x equals a. So we call that the m sub tangent on the lab is what the terminology I use there. The interpretation of this slope of the tangent line is the instantaneous rate of change of y value per unit of x. As an example, what we've seen, we started off with all this, if the f of x, the generic function I'm talking about up here, happens to be the special case of a position function, then when we do this derivative process at a point, we get the velocity. And the velocity is the change of position per time, because my function is in this position is the y value and time is the x value. So we're doing a change of position for time, which is feet per second. And if you're dealing with the velocity function, if the velocity function is the original function, and when we do the derivative, we get the acceleration function, which is the change of velocity per time. And I put out here on the end to make sure it's clear. Velocity is in feet per second, and I'm changing that feet per second every second. And if you simplify that compound fraction, you get feet per second squared. It's the standard way of writing acceleration. Okay, does that all kind of sound familiar then? Just a review. What we need to know. Questions, anyone?
Mr. Gaddis,
Yes, question. Yeah.
last night for the homework, this is like a general question.
Okay.
I found a trick to do derivatives. I don't know if it works all the time, but what I did is I took the exponent and I multiplied it by the constant in front of the x, and then I subtracted 1 from the exponent.
That's interesting. How did you come about that trick?
I don't know, I don't remember.
Well, that trick is a clever trick. We'll actually study that trick in the next block of material. For now, we will do our derivatives by the definition, as we've done in class. So on the test, when you do your derivative, tricks are not allowed yet.
No.
Next block, we'll study lots of tricks, as you call them, and we'll learn many ways of doing derivatives beyond simple polynomial, which are easy tricks. Harder tricks are more elaborate and more interesting. But for now, we'll just use the definition to determine derivatives on this one. Okay? Good that you figured out that trick. I'm glad you saw that and made that observation. Remember it for the next block, you can use it effectively then. Okay. And then we'll go over homework questions. I know I think Risen posted a post about a question. I didn't see it till this morning, so I didn't get a chance to respond, but we can go over that today. The next bit I wanted to review is the derivative. So we're going to this board. At any value x is the function time of x equals the minute h goes to 0 of f of x plus h minus f x over h. So this gives me, I can say all the same things, basically, that I said over here for a point. I can say this for this function, that it gives me the slope of the tangent line at any point on the original function. Rather than just at point A, I now get the slope of the tangent line at any point. It also gives me the instantaneous rate of change, not just at that one point x equals A, but at any point on the function. It gives me the velocity not just at x equals A, but at any point on the position function. So this is just the same concept, but it's generalized to any x value, so it becomes a function. And with that regard, you should then see the similarity of the notations. If I wanted to find the slope of the tangent line at a particular A value, and I have created this function, if I've created this function, and I now say, what's the slope of the tangent line at the point x equals A, what do you have to do? Simply plug that A into this function. This is now a function. So once you have this, then m subtangent at x equals a is simply found. I plug in to f prime of x. So the output of this function, the output is the slope of the tangent line, which is the instantaneous rate of change. Okay. The whole point, again, is the output of this function, output of f prime of x, is slope of which means it's an instantaneous rate of change, and so on. In terms of physically, geometrically understanding it one more time in review, what's going on when you look at this definition of derivative? Like, let's take the derivative in parts. Let's go back over to I'm going to go back over this board for this minute where we had the point derivative. First point. So this, we just wrote a whole big board full of information saying that this is basically giving me the slope of the tangent line, instantaneous rate of change. Well, let's break it down geometrically. The stuff in the red box right there, what is that actually giving me? Slope formula for a secant line. Okay, so this is change in y. You should see this as slope formula. This is change in y over change in x.
Yeah, that's what a derivative
H value is effectively just the distance that you move your x position, and then you calculate a y value with that new x position and the original y value. So you got change in y over change in x. So that's called the slope of the secant line. So this is the slope of so what makes it a tangent? What actually makes it a tangent? What did it say on the lab when you read that lab that you turned in? I just handed back. Or in the instructions. Tangent line is this limiting position of the secant line. Do you remember that?
Yeah.
If you take a curve like this, if this number here on a coordinate system, if this number here is a, and this number is a plus h, that distance, delta x, equals h. And if this is f of a, this is f of a plus h, that distance is delta y. And so what we've created there is a secant line between 2 points on the curve, and that line, that red line, has a slope of that. Okay, but then what makes it become a tangent line? How do you convert from a secant line to a tangent line? Yes, 18. Suggestion here, Chloe, did you have something?
Is it
Yeah,
when
go
the
ahead.
distance between the two x values is 0?
Yes. To get a tangent line, you can only touch at one point. But to create a slope in algebra, you had to have 2 distinct points. So to get the slope, you had to have 2 distinct points. But if we let, as Chloe said, the distance between those points shrink to 0, then effectively it goes down to a single point. So this part right here is what turns it into slope of tangent. When you take the secant slopes and you take that limit, you're getting eventually the tangent slope. As I shrink these 2 points closer together, shrink this point close to the a value, by letting h go to 0, if I shrink that down to here, then I eventually get this tangent line as h goes to 0, shrink that point in close, and you get a tangent line, and you have the slope of the tangent. Okay, so I just want to do a little bit of review. One of the comments I have, I think about this lab a little bit too. So on the test, for example, coming up Thursday, you'll need to be able to, one of the questions, I'm just going to give you a heads up, one of the questions is going to be to discuss what we've just been discussing, meaning you tell me what the definition of derivative function is, and then talk about that. What does it mean? It's one thing to be able to calculate it. It's one thing to plug in correctly and evaluate the limit. But now, tell me what it means. It's got to be more than just simply I can calculate the number 7. I mean, what does it mean? What does that 7 mean? Okay. And how does it come about? Other than the magic of, well, we let h go to 0 and we get this thing here. Where did that come from? Where did all that start with? It started with, as Joe said, slope, change in y over change of x. That's where we started, right there. With this. So you need to be able to not only do, but to explain what it means. So that's one of your questions on the test. The definition of derivative function, and interpret it geometrically, what it means. There's one question you ought to get right. Easy. You know what it is. Other questions you want to talk about before we do something else? There's still another topic we haven't covered yet in the section. Plus, I assume there's some homework questions, so we've got something to do. Any other questions y'all have? If you want to ask about the lab, we can talk about the lab. The questions on the lab. I did not create a nice solution sheet like I did for the last lab, but I had several people do really nice jobs, so I have one in mind that I would like to use as an example, but I haven't talked to the student yet if I can use their paper. So once I do, I get permission from the student, and I will share that with everyone as an example of a really nice lab. Several people did great. Some people had some struggles with it, but generally it's supposed to be a not too difficult lab. Okay. Well, what about questions on the homework so far, other than Newton's method, which we haven't yet covered? So you had some homework you were supposed to be working on, and I think, Razor, which one did you ask about?
Was it 47?
Yeah.
I think it was 47. I know the answer.
37.
I don't know what's in the answer key.
Find the derivative function of number 47. Okay? We'll do that over here. On 43, to the back of the book, once you get but I'm not going to.
He's like, does it matter?
No. Question is, the book says use z minus x form of the derivative. I don't care. I think just stick with h goes to 0 is the easiest way to do it on all of them.
Yeah.
On the test, I'm not going to say do it by the z minus x method. I'm just going to say do the derivative. I'm going to assume that means h goes to 0. Are we clear on that? If you want to use z minus x, you're allowed to, but I'm not going to require you to. And I'm going to only do it with the h goes to 0. You have the freedom to choose that if you like. So f prime of x, by definition, is limit of secant slopes. Secant slopes is delta y over delta x. So how do I find delta y over delta x? Well, my delta x is h. Delta y is the difference of two y values. So that's going to be x plus h is the next y value. And then the first y value is just f of x. So this is, again, I'm visualizing in my mind each time. I'm visualizing this as change in y over change in x. In fact, you know what? Sometimes I get a little careless, and I do it the old school way. Instead of using h as my limit variable, I'll actually do it this way. I don't know if I figure something out. What if I put a delta x right there? Goes to 0. I put a delta x right there instead of an h. And I put a delta x right there instead of an h.
That makes sense.
It works for me, and to me is easy as the h. The only thing is now you got two symbols that mean one thing. Delta x means one thing. It's not delta times x. But whatever, the book uses h, so I've been using h because that's what the book uses, but older books used to always use delta x because it kind of made more sense, but then some students got confused with delta and x. But anyways, so what does that mean? F of x plus h.
Are you going to just plug in x plus h into the formula?
Okay.
So you
3
get
times
3
square root of x plus
x
h.
plus
That's
h.
right. Good. Thank you.
Minus
3 root x.
over h.
Yes, I agree with that.
Okay.
I think Rezo suggested I can factor a 3 out of that, and that's absolutely correct because we learned in limits back last chapter, if you have a constant multiplier, you can factor that out. Sure, let's factor that out. I don't have a problem with that. Sounds like a good plan. So 3 times limit h approaches 0,
You don't need to go that far.
square root of x plus h minus the square root of x over h. Here's where you need a trick.
A trick? I thought you said no tricks.
Well, wait a minute. I said no derivative tricks. This is an algebra
Trick is-
trick. This isn't a derivative trick. This is an algebra trick you learn in the pre-calculus.
Oh.
We're going to rationalize the numerator. Rationalize the numerator. I remember how to rationalize way back in algebra.
Oh yeah, that thingy. Oh gosh, no.
We wouldn't want to do anything too rational here. We might so how do you do this? I remember. Multiply by the conjugate.
Yeah, conjugate.
Someone break it.
Oh my gosh, the complex conjugate. Oh my gosh.
Oh no.
This has me geeked. Gosh. I'm bugging right now. Oh my gosh, I remember this.
So if I choose the conjugate of this two terms, the conjugate is the same two terms with a plus sign or the opposite, whatever's up there. I'll multiply top and bottom by that same conjugate because I want to multiply by the number 1. But why would I choose that conjugate? What's that going to do for me?
It's gonna get rid of the square roots.
Now this is the factoring of the difference of two squares. A plus b, a minus b.
Yeah. Yeah.
This is 3 times the limit. H approaches 0 of. Now the denominator I'm just going to leave as h times, and I'm not going to distribute the h. I'm just going to leave it as x plus h square root plus x square root. But in the numerator, once again, I see this as a plus b times a minus b. And that's the whole reason we choose the conjugate. because now I have a minus b, a plus b. That's the factoring of the difference of squares. So I get the square of this, the square root of x plus h squared, minus the square of that.
Oh my gosh, that's convenient.
That's nice because I need some more. Can the camera pick up over here, or do I need to move to another board? Are y'all able to see that on the right side of the board there?
Yeah,
All right.
if it zooms in.
Come in just a little bit more.
Yeah. Yeah. Yeah.
One more time.
Oh yeah.
So 3 times the limit h approaches 0, and this becomes x plus h minus x over h times that stuff, square root of x plus h plus the square root of x.
Well, guess what? We're not on home stretch yet.
We're not.
Now the x's cancel or add to 0, if you will. They add, like terms add up. And got the x is adding to 0. Then we've got the h's that cancel top to bottom because it's a factor.
Yeah.
And you get 1 over square root of x plus h plus the square root of x. Now if we use the continuity theorem, we get 1 over the square root of x plus 0 plus the square root of x.
Wait a second, that's just 2 root x.
b times 1 over 2 root x, or 3 over 2 root x.
Got him.
I'll accept that. You don't have to rationalize that final answer. You can leave it as is. But we use a rationalization process from algebra in order to restructure our indeterminate form. We started off once again with indeterminate form, and even after factoring out a 3, I'm still in an indeterminate form. And seeing any kind of factoring was complicated, but if I saw this as one of 2 factors that will clean things up for me, then it made it easier.
Yeah. What was that trick called?
Rationalizing.
Rationalizing?
You rationalize the numerator.
Yeah.
Just
think I
notice,
heard it.
notice after I multiply by this, over here, the numerator does not have radicals in it, but the denominator does.
Yeah.
So oftentimes in high school math, you're made to rationalize the denominator. You got a square root of 3 in the denominator, you multiply by square root of 3 over square root of 3. Okay, great. There's not really a point to that, in my mind, other than back in the old school days, we used to like to have the radical on the top for some reason. In this, we're doing this particular type of problem, the radical in the denominator is actually works out better for us. So we rationalize the numerator rather than rationalize the denominator.
I always thought it was called, like, destroy the radical or something like that.
Well, that's what I thought they told us back in the 60s, you know, when they were spraying.
That was good.
Okay. Other questions on that? Anybody real quick? Anything? Another one, or you? That would be the biggest question. You all see how to handle this square root problem now? It's an algebra trick that you saw in pre-calculus, but it's probably been a while, so it's a good review. Now, we'll try to do it with an H. Okay. Question is number 43. Can we do it with an H? Okay, sure, we'll try. Let's see what happens. Okay. So 43. read it to me, please?
F of x equals 2 over x plus 1.
Like that? Okay, so once again, f prime of x equals, I'm going to try to do it h approaches 0 now. That's f of x plus h minus f of x. Hey, can y'all see that over there, Davidson? Is that zoomed in enough?
Yeah.
Limit h approaches 0. Now I'm going to do the same game. I'm going to evaluate f of x plus h. What does that mean again? Plug the x plus h into the variable of the original function. I don't just add an h on the end, as I see some people do. I literally plug x plus h into that. So that gives me a 2 over x plus h plus 1 minus. And then I plug an x into this. That gives me a 2 over x plus 1 over h. At this stage, you still have an indeterminate form, and worse, you have a compound fraction. You have fractions inside of a big fraction. In pre-calculus, you learn how to handle compound fractions, to simplify them. And do that first. So how do you simplify a compound fraction?
Get a common denominator.
Find a common denominator, that's right. Now, we can do it in one of two methods. We can either add the numerators together with the common denominator and then do some inverse multiply, or another trick, algebra trick we learned in pre-calculus, is we could just multiply the top and bottom by the least common denominator of all of the fractions. Think of this as h over 1. The least common denominator is x plus h plus 1 times x plus 1. Oh, God. X plus h plus 1 times x plus 1. I'm going to do the same game here.
That's dirty.
I'm multiplying by 1 again, just like over there, but instead of choosing, in this trick, instead of choosing conjugate, the trick is I'm choosing the least common denominator of all the fractions. And I see 3 fractions, one of which has a denominator of 1, so that doesn't really affect the LCD, least common denominator. So now I'm going to multiply the entire numerator by this stuff, and then the entire denominator by that stuff. So when I distribute all of this to the first term, the x plus h plus 1 cancels with that x plus h plus 1, so I get 2 times x plus 1.
I think it's a little different, though.
Okay.
Now, when I distribute this stuff here to that fraction, x plus 1's cancel, so I get minus, which is a minus right there, 2 times x plus h plus 1. My ink just ran out. In the denominator, I'm just going to leave it as h times that. I'm not going to distribute the h into this. H times x plus h plus 1 times x plus 1. So notice that little game that we did, that trick, if you will, this time by multiplying by that special number 1, created, instead of a compound fraction, now we just got a regular fraction. We don't have fractions inside a fraction. So now I can combine like terms and see what happens.
That's good.
Okay, so I've got a looks like a 2x and a minus 2x, so that goes away. I've got a 2 times 1 and a minus 2 times 1, so that goes away. And then I've got a minus 2 times h over h times x plus h plus 1 times x plus 1.
Oh my gosh, and the h's cancel out.
Yes, the h is now canceled out. So bringing my work over here, I've got negative 2 in the numerator. I've got the rest of the denominator after canceling out that h. And now I can apply my continuity theorem. So this becomes negative 2 over x plus 0 plus 1 times x plus 1.
That's just x plus 1 squared.
Negative 2 over x plus 1.
That's cute. I love it.
Did it with the h equal, it goes to 0 method rather than x, c goes to x method. You can do it either way. I don't, doesn't matter with me, but it is doable with the h goes to 0 method. But again, you need a special algebra trick. You have to either, what we did there was you either had to multiply by the number 1 to clear your fractions, or you had to actually combine the fractions and then invert and multiply your because you got a division. Think of this as division. So the other method is combine the 2 fractions in the numerator and then think of this as division. So you invert and multiply it, you come out with the same answer eventually. Either way, it works. Follow that? See, can you see the 2 methods? Add the fractions and then invert and multiply, or clear the fractions by using the common denominator multiplier. And you're there also. So we feel better about that one now. Okay, good. I'm accumulating markers here. Got them on the table. I'm carrying them around with me because I don't want them to get away from me, and I'm afraid they'll escape. You know. Okay, I'm just checking the time. How much time we got? We got 30 minutes. Good.
Oh yeah.
30 minutes. We can do Newton's method.
We can do a what?
Called Newton's method. First,
Oh,
before we do. Pardon?
Whole Newtons, is that what you said?
No, Newton's.
Newton, like as in Sir Isaac.
Oh, Sir Isaac.
Not like the cookies you like to eat, or
I never eaten that thing.
for the amount of force in metric system, or which happens to be named after the same person, but that's
You know,
okay. Before we get to what's called Newton's method, this whole discussion now is leading up to what's called Newton's method of finding truths. An important method that Newton figured out from his work in calculus. It is related to how your calculators are actually programmed now today to find roots of functions. So engineers have to understand this so they can build your calculators to do their job. Back in the day before we had calculators, some of us still had to learn how to do this because, well, that's what we had to do. Anyways, it's still a good method to understand. It starts with understanding what's called local linearity. So first we need to look at what's called local linearity. What do I mean by that? Okay, so I take a function. I'm gonna exaggerate my function here a good bit so we can really see what I'm talking. Try to see what I'm talking about. There's a function y equals function of x. Okay, good. Archetypical function. Now, let's suppose this number right here is the number c. Then that would mean this number right here is f. That's easy. If we go over a small distance, and my small distance is going to be greatly exaggerated so you can see that, I can emphasize what's going on. If I go over a, quote, small distance, delta x, and what's the value of that x coordinate on the axis that I just created?
Delta x.
That's c plus delta x, right? I'll look at that.
Sounds like the twins from the sun. The Shining.
What was that?
They just said something in unison, and I said that was like the twins from The Shining. I'm just cultured, making movie references over here.
We got the Shining going on. That's kind of scary. I mean, Halloween, yeah.
Yeah.
Okay, so what's this point on the y-axis I just created?
Is that f of c plus delta x?
Excellent. Wow, we got some unison going on. We got a whole bunch of. That's good. I'm glad to hear it.
Never seen The Shining, actually.
Oh. I come in here and draw a tangent line at C.
Hang on. Okay, tangent. He's right. I thought he was going to deceive me. Okay.
Hey. Excuse me a second.
It's a magic trick, see? I don't see. I don't have a concept of object permanence. He just when he's out of sight, he's out of mind. Well, he's back.
Okay, so here's my tangent line. What is the slope of that tangent line?
Well, if you want to get really technical,
I'm not necessarily asking for a complete definition. I just want to know in symbols how you would calculate the slope
is it
of that
just
tangent.
f prime of c?
Yes.
Goddamn.
Good.
Oh, yeah.
Now here we need to understand a little bit about straight lines and trigonometry and similar triangles. So we're going to go over here for just a moment and remind ourselves about that. So if I have a triangle like this, let's say that this is 1 and a 3. And you would say the slope of the diagonal line is what? Rise over run, equals 1/3, right?
Yeah.
Good. What if I went out here to so this distance is now 6. A similar triangle. If this distance is now 6, what's the height of that side there? How did you decide that?
You put it in the slope.
What?
I don't know.
What in the slope? I don't know what you mean there. I think I do, but it's a little bit sketchy on what you're saying.
You know the 6. So you just like put it in the slope.
No.
How about we talk similar triangles?
Oh no. Recently.
I like my thingy.
So the ratio of 1 to 3 has got to be the ratio by similar triangles of
Yeah.
5 and 6.
Yeah, that's what I'm saying. 1/3 is equal to 2/6. You just gotta put it in the thing.
So this means that y is equal to 1/3 times 6. That I get by picking these easy numbers, you can easily see it's 2, but I want you to think about what I just wrote. What did I just write?
A fraction.
This is a slope
Oh, that's all you meant.
What does that 6 represent? Oh, that might be, how about delta x?
Oh
And my y
gosh.
value is my delta y. So that's the reason I went through all that, even though that's all stuff you knew from 8th grade algebra. I wanted you to think about that for a minute. Once again, the amount of y here is simply the slope rate of change times the amount of x change. So if I didn't put 6, if I put there, then how would you find that number? Well, you multiply the slope rate of change times d. Y'all follow that? Okay, so back over here,
Oh my.
well, look, there's a right triangle again. That's
No.
here.
No. This can't be.
No, it's kind of like the A team. You got to love it when that plan comes together. No? Long ago. So
I remade the movie so I can see it.
Okay, let me see. Yeah. So here's my delta x, right? There's my delta x. What I'm trying to figure out is, what is my delta y right there? That's not really the number. Let's not call that delta y. I'll use delta y for something else. Let me change that to, let's call it just d. Let's call it. Because I want to use delta y for something else in a moment. How do I calculate d based on the information I've got given and the picture I have drawn?
You multiply.
Divide that change of
Times plus the tangent line, which is f prime of c.
Come again.
Yes. D equals the slope rate of change, f prime of c,
Times.
times the amount of distance you want to cross, which is delta x.
I love it.
All agree with that?
Yeah.
Okay. Now I'll answer one more question.
Okay.
Knowing this, can you tell me a y coordinate of that right there?
You probably shouldn't be looking at me.
I'm looking at this point on the tangent line. What is the y coordinate of that point on the tangent?
Oh crap. Well, it's just.
Yes.
See.
Okay, I can't plug in. To get this point, I had to plug in to on the function curve. If you're on the function curve, you can just plug into the function and get a y value. But that point is not on the function curve.
So.
So I can't use the function curve directly. But I do know at a certain height, how tall is it? How much is right here?
F of C.
Yeah.
That's just f of c, isn't it? Isn't that what that says right here?
Yeah.
And then we just figured out how tall that much is right there. So this number right here is what? This number right here. What is this height? And I'm trying to figure out that height right there.
F of C plus D.
F of c plus d, which we'll write it as f of c plus f prime of c times delta x, which is plus d, I agree. But I'm going to go ahead and substitute in what d is. We follow that? If I take this distance, this height I already knew, and I add in this amount of height that I just calculated, I get this new height. Well, the thing is, folks, again, I exaggerated my picture. If this delta x is small, do you see that this number, this purple number here, this height, is a reasonable approximation of that height? Now, it's not right now. There's a big, right now, there's a big old error. See this mountain right here. my error of approximation. But do you see that if delta x is really small, that my error of approximation would be also equally very small? So as long as I'm nearby to a point on the curve, then what this is telling me is I can view the curve as being locally linear, meaning I can use the tangent line. How do we work with the tangent line? Gritters. We've been doing this for the last several days. I can use the tangent line as a reasonable approximation of the curve. All that?
Yeah.
If I'm close by, then the linear function called the tangent line will approximate reasonably this curving function called f of x. Questions on that?
I'll take it.
This is what's going to do it right here. This idea. That's the equation. Well, that's what Newton's method's based on. Is that understanding of local linearity? So how do we use it? Okay, let me give you an example. So now we're doing Newton's method. Given the function f of x equals x cubed minus 2x minus 1, that should have a 0 between 1 and 2, x equals 1, x equals 2. First thing, show me, tell me why. How do you know? Explain. Explain why f of x has a 0 in the interval Can I do that for me?
That sounds like
The
intermediate value theorem.
Ding, 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 ding. We just got like 10 brownie points right there, at least. Wow, intermediate value theorem. So how do you use that? That's right.
Well,
You would calculate the y value at x equals 1 and x equals 2.
well, firstly, it has to be continuous
Yeah, so why is it continuous?
by the continuity of algebra of power of polynomial functions.
I mean,
Was-
algebraic function, which includes all polynomial functions. That's right.
Okay.
F of 1 is equal to -2. Did I do that right? I think so. -2. Which is less than 0, which is less than, let's see, if I plug in a 2, 8 minus 4 minus 1 is 3, which equals to f of 2.
I love it.
So because my two y values are on either side of 0, then there has to be some x value in that interval that causes f of x to equal 0. Therefore, f of x equals 0 for some x equals c in in the open interval, 1, 2. Okay. Good. Intermediate value theorem. So intermediate value theorem doesn't tell us what the value is. It just tells us there is a value. Well, how do we find that value? That's where Newton comes in, and local linearity. So this graph, I think this graph looks something like in 1 and 2. It's coming. I think it's coming up something like that. That comes up back up here somewhere, whatever. Anyways, so it's doing that. What we're going to do is we're going to pick an endpoint as an initial guess of a 0. And then we're going to use local linearity. So let's eeny-meeny pick this one. So we're going to say my first guess, x1 is equal to 2. So these are my sequence of 0 approximations. x1 equals to 2 is not a very good approximation because why? Well, at x equals 2, the y value is 3. That's not anywhere close to 0.
Yeah.
But this is a 3. Okay. But more important, watch what happens. What if I find the tangent line at that point? Y'all, can you zoom in on that a little bit for them? Y'all see this?
No. Can you please
We got
zoom
a
in?
point on the curve at 2. I drew a tangent line, and what happens to that tangent line? It comes down and intersects between the 0 and the 2. In fact, my picture looks like it's pretty close to the 0. Well, how can we figure out that will be my next approximation? So the idea is my second approximation will be the 0 on the tangent line. So x2 will be some number. It will be the x-intercept on tangent line at x1 equals 2. So one more time, I'm trying to find the 0, the x-intercept of the function f. I'm going to do it by approximating using tangent lines, assuming that in a nearby region, the curve is almost linear. And we're going to use the tangent line as my linear approximation. All I have to do to get this next approximation is I have to find the equation of the tangent line. Equation of tangent. How do I find the equation of this tangent line right there?
Take the derivative of the function.
I first got to know what slope, and I got to know a point. Well, the point is easy. What's the point on the tangent line? It happens to also be on the function curve itself. The point is 2 comma f of 2, which is 2 comma 3. Good. This is a review from the lab. Now, how do I find the slope value that I'm so curious about?
The derivative of the function that we have.
Can you hear you say it again?
The derivative of x to the third minus 2x minus 1.
Yes, I have to do the derivative to find the slope. So the slope is simply going to be f prime at 2. Are we clear on that? So you need to find the derivative. To save time today, I'm going to tell you what the derivative is because I have to remember the tricks that Brittany was telling us about earlier. So I'm just going to pretend like we don't know this, but so f prime of x is 3x squared minus 2. Okay, there we go. That was easy. On the test, you get to do that by the definition. Are y'all with us on that? Actually have to do that. So now I can plug in and find out. Let's see, what do we got? So this is 3 times 2 squared minus 2, which is what? 12 minus 2 is 10. So I got a slope of 10. Okay. So what's my equation of my tangent line now?
Well, do you want to do point slope form?
Yes. So y equals, or y minus 3
3
equals
Equals
10
10.
times x minus 2. Point slope, that's exactly right. Now, my objective is not to just get a tangent line equation. My objective is to find the intercept of the tangent line equation.
Okay.
X-intercept. So how do I find the x-intercept of any equation? How do you find the x-intercept? Take y0, okay. So we're going to go in here, and we're going to substitute a 0 in there. So that's going to be negative 3 equals 10 times x minus 2. So negative 3/10 equals x minus 2. So x equals 20/10 minus 3/10 is 17/10. X equals 17/10, or about 1.7. So my x2 is 1.7.
Yeah.
That's a better approximation of the actual 0 of the function than it was a minute ago. Y'all follow my get on that? That's what we're going to do next. We're going to do it again. So now, if I zoom in, so I'm zooming in real tight right here. I draw a picture again. I got my curve coming through like this. My first approximation was here. I went up, and then I drew a tangent line down. That gave me my second approximation. So this is x1, and this is x2. We're going to repeat the process. We're going to go up here. We're going to draw a tangent line. And that point right there where it intercepts the x-axis, that's going to be x3. Y'all follow this? How do we do that? Let's do it one more time. What are we going to do to find this equation of this second green tangent?
Take the second and use the point from the last one.
Same thing, right? So what's the slope of this tangent line? I'm on this tangent line right here. This is the slope 10 again?
Yeah.
Oh, so it's every time of 1.7, which Jacob just told me is what? 6.6. Like, so that's rounded or that's exact? Yes. Well, rounded to 6.67. I'm going to take a few more decimals so we get a little more accuracy. Okay, there we go. I need a point, so I also need a point. Point is not the same point it was a moment ago. It is at 1.7, comma f of 1.7. 1.7, comma. So if I plug in f of 1.7, I get a y value. What do you get? Up here, up here. Are we with me? I'm just doing the same game again, writing a new equation. 0.513 approximately, okay? So this gives me an equation again. So I get y minus 0.513 equals slope of 6.667 times x minus 1.7. Okay, I wrote an equation tangent line, but this time, why did I do that? So I can find the x-intercept. How do I find the x-intercept?
Plug in 0.
Y equal to 0. So y is equal to 0. I get negative 0.513 equals 6.667 x minus 1.7. So negative 0.513 over 6.667 plus 1.7 equals x. That'll be x3.
What even is this number?
we're in, y'all follow that? What'd you get? Did you get a number?
1.623.
1.623, good. I'm going to stop and write a generalization of that process.
Okay.
What do you observe each time? So, like right here, to solve for my new x, I took the, I had this negative of the y value, because you do y minus 1, 1. And then I divided by the 10. Where did the 10 come from?
The slope of the.
And then I added the x value on to that. Over here, I had negative of my y value. I divided by the slope and added the x value onto it. So we've generalized that real quickly. X, so n plus 1, the next approximation, I'm writing a pattern, is equal to, we've got the negative of the y value of the previous one. So negative of f of x of n over the slope of the previous one, which is f prime of x of n. Then we added the previous x of n.
Wait a second, this is looking familiar. Oh, crap.
So your calculator can easily, with a good engineer and a software programmer, can program this fairly easily, and then tell it when to stop, meaning once I get a certain decimal of accuracy, I stop, and I give you my answer. Your calculator otherwise would run forever because it can't actually ever hit it. It's a limiting process, but once it's within a certain tolerance, it says I'm good. So you can take out your calculator and do a zero command on the function I had up here a moment ago, and you'll find out that within probably about the next one, we'll be within probably 4 decimals of accuracy of the exact answer. So Newton's method is pretty quick to get there. There are other methods that are even quicker. Okay, so what is 1.618. So we're real close within just 3 steps. We're there. Okay, so homework is practice more, and on the homework are some Newton method examples. So go home and try a Newton method. Try to get an approximation of the answer as directed. This is the general process. The next x is always calculated on the previous values. Right, see you all tomorrow.
And I even have one more in my notes.
I'm pretty sure it's a yes or no question.
Can we just read him?
We don't have to take this quiz now.
Josh, don't say things like that. You're gonna make me depressed.
Because I know that it's going to happen.
I'm expecting you to lose.
Our test
I'm
is
gonna
class average is 60 something. How are we going to pass this quiz?
That's Stacy's.
You can call me on the regular phone if you want. Let me see. It is extension 4865. All right, can you hear me?
Yes, we can hear you. Can you hear us?
Yep, I'll hang up now.
I have to confirm with you. Absolutely. Okay, so what we're doing is right now we're arguing over the scholarship